Assalamualaikum warahmatullahi wabarakatuh. Today I would like to talk about logic circuit simulation of 4-bit adder-subtractor and 2 to 4 decoder with enable. In computer organization and architecture, circuits form the fundamental building blocks that enable a computer to process information. These circuits made up of logic gates and combinational or sequential elements perform essential operations in computers. The purpose of the 4-bit adder-subtractor is to perform arithmetic operations in a computer. It can add or subtract two 4-bit binary number depending on the mode input. The purpose of the 2 to 4 decoder is to select one output from 4 possible outputs based on a 2-bit input.
This is the truth table for 4-bit adder-subtractor and 2 to 4 decoder with enable. And this is the logism circuit for 4-bit adder-subtractor and 2 to 4 decoder with enable. Next, we will demonstrate how these circuits work.
Hello everyone, today I will be explaining the operation of the 4-bit adder-subtractor unit, a fundamental circuit in digital logic that efficiently performs both addition and subtraction using a single design. So first, I will explain about the inputs, which is input A, input B, and the mode control. So first, input A and input B. These are the two 4-bit binary numbers. When we want to operate on each bit, goes into a different full adder block. So for the mode control, this was the single crucial switch that determines the operation. It selects whether the circuit adds or subtracts. If the mode control are 0, so the circuit will be perform addition, which is A plus B. But if the mode control are 1, the circuit will perform subtraction, which is A. Okay, so for the main result of the operation, I will explain about the sum. Okay, the sum is what's the main result of the operation. If the circuit is adding sum, if the circuit is subtracting. So for the carry out, this was the final carry bit that generated by the last full adder. Okay, now I will be explain about the wire color. So in the provided diagram, different shades are used to visually separate the signals. So for the lighter color, I will show here. So the lighter colors are appear. So the lighter color often used for input or general data lines. And the darker color, which is dark green, often used for output signals or sometimes for control signals operation. I will explain about the sum. Okay, the sum is what's the main result of the operation. If the circuit is adding sum, if the circuit is subtracting, sum will be difference. About the carry out. So this was the OR gate. It's one of the 3 basic logic gates along, and it is a fundamental building blocks of all digital electronic circuit. It performs the operation of logical instruction. So here I will put 0, 1. So when I put in A 0, 1, 1 equal to 7, and B 1, 1, 1 equal to 15, so the carry out will be appear number 1. But when I on the mode control, the carry out will be 0. Because so when I put in A 0 1 1 1 and B 1 1 1, so the carry out will be 1. So how it happened? Because when the A was 1 and B 1, so the carry out will be 1. Carry out will be 1. But when I turn on the mode control, the carry out will be 0. Because the B was turned 0 here. And the carry in was 1.
Hello everyone, you can see here 2 to 4 decoder with adder. Now I explain binary number. When input A equals 0 and input B equals 0, so output is 1. You can see output B0 is active. That means high. If input A equals 0 and input B equals 1, output is 1. You can see output B1 is active, which means high. When input A equals 1 and input B equals 0, output is 1. You can see output B2 is active. That means high. If input A equal 1, B equal 1, so output is 1. You can see output B0 is active. That means high. Okay, input A and B for enable. Okay, this is not gate. Not gate, which means as an inverted, it convert an input 0 from A or B to 1 to activate output B0. For binary number code 00, cannot change A equals 0, B equals 0 to 1 and 1, which is required by KN for light up. This is AND gate. Every line output B0 until B3, controlled by gates AND. In simulation logic, on the circuit line show the signal flow binary number. Okay, for the light green, it shows signal high, which means that is bottom full flowing. For output B0, B1, B2, B3. While dark green, it shows signal low, which means no voltage or very low. Flow number 1 or 0 is flow from input A and input B. Represent cannot and flow login and gate. Only when and gate success called signal 1 and 1. So the output change light green for high.
The circuit functional. For 4-bit adder-subtractor, this unit performs either addition A plus B or subtraction A minus B for 4-bit binary numbers controlled by the mode M signal. circuit core, it is built using full adder unit connected in a ripple carry configuration. Subtraction function. Subtraction is implemented using the two complement method. Role of XOR gate. The external XOR gate connected to each B into input is key to this function. When mode +1 subtract, the XOR gate invert B yielding the 1's complement, and the n equal 1 signal is also wrote to the carry in to complete the two complement. For 2 to 4 decoder with enable 2-bit binary code from input A and B into a signal active signal on one of the 4 output lines B0, B1, B2, B3. The circuit use AND gate and NOT gate. The AND gate ensures that only one output light up as it require a perfect 1 and 1. The NOT gate is used to invert an output 0 to a 1 so that the AND gate can activate. Enable acts as the master switch. The circuit will only function output can light up when the enable input is height 1. CPU application. 4-bit adder-subtractor used in arithmetic logic unit ALU of CPU to perform arithmetic operation during program execution. 2 to 4 decoder with enable used for memory selection and register reselection. It ensures that only one memory block or register is activated at a time.
These are the challenges that we face during designing and simulating these two circuits. In 4-bit adder-subtractor unit circuit, we need to understand and implement the subtraction operation using the 2's complement method. This required us to ensure the XOR gates were correctly connected to each B input and that the mode signal was input into the carry in of the first full adder. This circuit involved cascade carry wiring. We needed to ensure the carry up from each full adder block was precisely connected to the in carry of the next block to obtain the correct 4-bit result, while also accurately handling the overall circuit's carry out and overflow output. Next is the 2 to 4 decoder with enable circuit. We need to ensure wiring logic for every AND gate was precise. We needed to ensure that the unique combination of inputs for each output was absolutely perfect, as any error would cause the wrong output to illuminate. This circuit involves debugging in Logisim. Difficulty arises in identifying minor wiring errors, particularly in the connection of the NOT gates and the enable line, which could cause the entire circuit to fail to function as expected in the truth table. In summary, through this project, we successfully simulated two critical basic building blocks in computer architecture. Firstly, the 4-bit adder-subtractor circuit proved how complex arithmetic functions such as addition and subtraction using 2's complement can be performed solely through a combination of logic gates. This function forms the core of arithmetic logic unit within any processor. Secondly, the 2 to 4 decoder circuit demonstrates control and code translation functions. The circuits allow a 2-bit input code to be translated into one of 4 unique output lines, where it serves as the foundation of memory block selection. Overall, the simulation of these two circuits, which rely on AND, NOT, and XOR gates, provides a deep understanding of how simple components can be combined to form a central processing unit capable of handling both data and control.